So since the dawn of space exploration and human spaceflight in the 60s with NASA and the Gemini, Apollo programs, only a few hundred people ever were, lucky and privileged enough to go to space. And things have been changing, in the last decade. Numbers have been slowly going up thanks to the advent also of other private companies or other countries being more present and developed in the space industry. But over the many billions of people that ever lived on the planet, only a few hundred people ever went space. And so there's a kind of similarity in a sense with the early development of aeronautics, where in the early 1900s, only a few hundred people were privileged, lucky enough to use an airplane and travel with that new transportation system. So we hope that the same in the space exploration currently, and would be able to increase the number of people going to space by many folds. Imagining myself to be able to contribute on building any other space station around the moon, going to the surface of the moon and perform some experiments there, that would be amazing.
Welcome to the Blue Economy Primer, a New Orleans-based podcast where you learn from the experts the practical tools and solution sets that will empower your community to adapt and thrive in a new blue era of rising seas and economic discontinuity. Today we have the pleasure of speaking with a NASA engineer and innovation pioneer with an eye on the special technologies and systems that will facilitate humanity's leap to a multi-planetary species. As part of Deep Blue Institute's interest in advocacy for technologies that support maritime urbanism, or floating cities, we recognize that many of the concepts and tech innovations that support extended spaceflight and habitation provide proofs of concept for the solution sets that will facilitate the realization of remote ocean-based habitats serviced by off-grid energy, water, and waste systems. Our guest today has been following and supporting the link between these fields since 2017, when he and I met and collaborated on a number of presentations. Be sure to stay tuned after the closing of this podcast when we ask Roberto about the Fermi paradox and how we may eventually discover life in other parts of the universe. Roberto, thank you so much for joining us on the Blue Economy Primer. Can you please introduce yourself to our audience?
Yeah, hi Greg. Thanks so much for having me here and for the great introduction. It's a pleasure. It's a great pleasure to be here. So, like you said, we connected back in the Bay Area around 2017. That's where I was living and working at NASA Ames Research Center. So one of the NASA centers located in Silicon Valley, Mountain View. And I've been working at NASA Ames since 2015, so almost 10 years. And I'm an aerospace engineer by background. And in the last few years, I've been working on some really neat new type of technology cutting-edge projects. One of them is called Astrobee, is a series of free-flying robots that we use inside the International Space Station. And they're used kind of like a mix between drones and space Roombas and research platforms. So they do, we do a lot of experiments, science and technology experiments, using the environment of the ISS. And then another project is called, it's a solar sail spacecraft. So it's a type of satellite that will demonstrate a new type of solar sail for the use of this technology in the future for space exploration.
Neat. So can you tell us from your point of view, what do you think is the link between seasteading or floating city technologies and the technologies that support humanity's adventures into space?
There's really a lot of commonalities here. If you think about it, space habitats or settlements on other worlds have a lot in common with floating cities. If you think about it, first of all, they are both kind of solutions of settlements in very harsh environments. So the need of very sustainable technologies is a requirement, and all kind of stuff like the reuse of all kind of technologies and life support systems, and growing your own food, and then like the harvesting of the energy and reuse of that have a lot of commonalities between the two.
Interesting. Do you have any favorite or key benchmarks or statistics that for you characterize your work or the importance of space exploration to humanity's future?
Yeah, there's it's more kind of like just a reminder about some numbers about space exploration. So since the dawn of space exploration and human spaceflight in the 60s with NASA and the Gemini, Apollo programs, only a few hundred people ever were, lucky and privileged enough to go to space. And things have been changing, in the last decade. Numbers have been slowly going up thanks to the advent also of other private companies or other countries being more present and developed in the space industry. But over the many billions of people that ever lived on the planet, only a few hundred people ever went space. And so there's a kind of similarity in a sense with the early development of aeronautics, where in the early 1900s, only a few hundred people were privileged, lucky enough to use an airplane and travel with that new transportation system. So we hope that the same in the space exploration currently, and would be able to increase the number of people going to space by many folds.
And I understand that you recently competed in the process with the European Space Agency to try to become a mission specialist. Can you tell us about that? And I understand you did very well. You weren't chosen, but did very well.
Yeah. I mean, it was an amazing process and experience. I competed with other 22,000 people, and I arrived in the last 35. So, which was, statistically is a really, really hard process and very, very low chance of success. And although, I got so close to the end and it was an amazing experience, it was at the same time a bit depressing because I put a lot of effort and hope in it. I thought I was gonna get selected in a sense, and unfortunately that didn't happen. So yeah, but anyways, like that kind of like reinforced even more my dream of wanting to become an astronaut and go to space. And so I understand that NASA has another process coming up? Yeah. So NASA, there's every 4 years, 3-4 years, NASA has their own astronaut selection process. And so hopefully I can apply for that and see if, I have better luck in that.
All right. Well, good luck with that. Obviously, we'll be staying in touch to see if you get on a mission. What do you imagine would be the type of mission that you may be involved with?
Yeah. So right now there's a lot of interest and attention focused on the bringing astronauts back to the moon with the Artemis program, and NASA is slowly transitioning from the International Space Station, which orbits the Earth, to another space station that will orbit the moon. It's called the Lunar Gateway. And so there's this big effort endeavor in moving on to deeper space towards the moon and deeper. So just imagining myself to be able to contribute on building any other space station around the moon, or even just going to the moon, to the surface of the moon, and build and perform some experiments there. That would be amazing.
Wow. Yeah. Mind-blowing just to think about. So I understand you've been to about 5 or 6 different NASA facilities, including obviously working at Ames for a long time. Regionally, we are very proud of NASA Michoud here in the New Orleans area, and the fact that locally, just 25 minutes away from where we're sitting here in the Garden District, Louisiana technicians are building the rockets that will transport the first woman to the moon. Maybe you'll be on the mission with her. What is your impression or takeaways from your visit to Michoud while you were here?
Yeah. So I was really lucky to get connected with someone who was able to give me a little tour of the facility there, Michoud, and it was incredibly impressive. I think it's one of the biggest hangars or self-standing facility I've ever seen. It's just like almost like a small city inside this huge manufacturing building where they have all the different stages and parts of the rockets, and they assemble them together and they put them together to the end when they ship them to Kennedy Space Center and they launched from the launch site in Florida. Yeah, it was incredibly impressive. Being able to see all the different parts, the different stages of the rockets, which is gonna be the most powerful and the biggest rocket that will go to the moon. And it was very well organized. So I think most of it is managed and used by commercial companies like Boeing and Lockheed Martin. I think Blue Origin is also working on some projects there for the human lander. So there's NASA is kind of like a supervisor of all these different sections where they are responsible for building the parts of the rocket. But yeah, so just being able to see all these parts of the rocket and then these most cutting edge facilities and machines that assemble and test rockets, they were really, really cool. Yeah, you don't get to know too much. That's a bit unfortunate because among the 10 NASA centers across the US, you don't usually hear about Michoud, or actually even before coming here I was a bit confused whether Michoud was located at the same place as Stennis Space Center. That's where they actually do the engine fire tests for rockets.
Where's Stennis?
Stennis is actually just across the border in Mississippi, okay, which is an hour away from here, east from here. So they're two separate centers, but Michoud is just very impressive. They have some of the most advanced technologies and machines to do their the assembling and the testing of the rockets.
Mm-hmm. Yeah, well, we've had a chance to talk to some other folks that have worked at Michoud related to offshore wind and all that, but I didn't realize that there was that much collaboration going on in terms of different companies.
Yeah.
On that, you've been in town for, I think, a little over a week and gotten to see a number of different organizations and meet folks that are involved in the different aspects of what we call our innovation ecosystem here in New Orleans. You visited New Society, you got to meet Tim Williamson, you visited the beach, you got to meet Rebecca Conwell, the executive director there. You got to meet and listen to Michael Hecht of GNO Inc. and talk about what's going on there. So can you give us a little bit of your impression of what you're seeing in New Orleans in terms of the innovation ecosystem here and how we're creating an environment where technologies, whether it be from Michoud or other sectors, could really start to make an impact on economic development and the world in general?
Yeah. So I got the privilege to attend some of these events, and some of the talks were just focused on the renewable technologies and the resources, use of the resources. So it was very impressive to hear that New Orleans and Louisiana in general are trying to have a much bigger footprint on transitioning our use of fossil fuels energy sources to more renewable sources like solar and wind and those whatsoever. So just hearing that there's a lot of really cool projects going on here, and that there's a huge attraction and investment in trying to make New Orleans the new nexus for this kind of transition for all these efforts. So that was very impressive to me, and I'm actually really excited. And New Orleans is actually really totally makes sense that this is being worked here in New Orleans, because it's such a fulcrum for all kind of different resources and technologies. Also historically, New Orleans has always been a place where a lot of cutting edge technologies were developed and built, and there's big influence from the maritime side, all the kind of this the gateway to all the the rest of the US. So it could totally be the place where everything can change.
Great. Well, it's always good to hear that, obviously. So aside from the, let's call it the more technical or professional stuff that you experienced here, any highlights in terms of food or music or experiences getting out around town and experiencing the unique culture that we have here?
Yeah, it was just amazing to. I don't know if this is just a special time, but I don't think so. As far as I understand, it's pretty much all year round. But I was able to go to a bunch of shows, jazz shows, and other music shows all around town, and they were just you see how the city is just so alive and happy and all together, just sharing these amazing cultural moments and music moments. So it was just really cool. And then of course the food is just amazing. Everything from seafood to meat or whatever, everything was perfectly well cooked, well done. So
well, we didn't mention you're actually originally from Italy. Sometimes we say here in Louisiana that we have a Mediterranean culture or a Caribbean culture. So I imagine there's probably some fun parallels in terms of lifestyle and all ways of life between Italy and New Orleans.
Oh yeah, I can definitely mention a few similarities, like the streets and the roads are reminds me a lot back of Italy. Just kidding, but no, for sure, the culture, seeing how everybody is just very proud of being from here, and sharing all the local culture. Same thing in Italy, everybody has such a strong cultural traditions, and with the upcoming Mardi Gras here, everybody is just so happy and excited about the parades and the parties in town. And then of course the food is just the other big kind of strong tradition here, which reminds me a lot of Italy. Of course, the weather in a sense can be also kind of linked to what I experienced in Italy. So I can totally understand why it's called the Mediterranean influence.
And where are you from in Italy?
I'm from Naples, the south.
And I imagine your family and friends in Naples must be very excited and proud about all the type of work you're doing at NASA and beyond.
Yes, absolutely. Every time I go back, I always bring a bunch of swag and all kind of gadgets from NASA, and then whenever I go back, I see them wearing it in the streets all the time. just bragging about me all the time. So it's very satisfying. Yes.
Yeah, well deserved, I'm sure. So to your specialty in terms of solar technologies and solar sales, but also solar energy in general. Obviously, the solar energy generation out in space is a key source of energy. Can you talk a little bit about the link of the development of those types of technologies and how those may be supporting or influencing solar energy on Earth?
Yeah, I mean, if you think about it, the sun is this huge source of energy up there in the sky, and we just need to if we don't use it, it's just in a sense lost. So we have so much opportunity by using the energy from the sun, whether it's from on Earth with solar panels, or there's solar farms. There's actually a few concepts of using some solar farms in space. Where you can collect. There's a few on the ground already, but if you go in space, there's no atmosphere, very little atmosphere, so you can use more power from the sun. If you collect with big mirrors all that energy in space, and then you transmit it down to Earth as a different form of electromagnetic waves, you can really make a huge use of the sun, the solar radiation. And then another way of actually using the sun in a kind of related project that I'm working on is with so-called solar sails. If you basically deploy a big metallic blanket, which is a solar sail in space, you can collect a lot of the energy, the solar radiation emitted from the sun, and you can use it to propel in space without using your own propeller, without bringing your own propellant. So it's kind of the cleanest and the greenest, most renewable energy kind of source to move around space. And then so it's very cool because it opens up a lot of really interesting missions that cannot be currently performed with other technologies. And so there's all kind of amazing opportunities by using the sun.
Mm-hmm. So on those types of technologies that you're working on and are being developed for space flight and for the space station, et cetera, we talked about how there are some parallels with how those could be informing or helping to prototype and scale floating cities or maritime technologies. Can you talk a little bit more about what some of those technologies may be as may relate to water and waste? And in fact, you had an experience where you were part of an experiment of being in sort of a habitat or biosphere for some time, which I imagine incorporated some of those technologies. I was privileged enough to do one of these missions called astronaut analog missions. So I was in isolation for 45 days with NASA at the Johnson Space Center in Houston, simulating a mission to Mars and back. It was an expedited mission. With how many people?
We are 4 people, without 3 people, so 4 people total. And so we were working together as a team, as a crew, to perform all kind of experiments and tasks that astronauts do in space. And so there's all kind of technologies that in general are used on the International Space Station, for example, or even in our simulation and our habitats. There were some simulated technologies that are used for that, and all kind of stuff that once you're in space, you have very limited resources that you need to bring with yourself, and you need to try and be as efficient as you can, being able to reuse and recycle as much as you can from all those resources. And so going from recycling even urine that goes, there's the usual joke around astronauts that coffee of today is coffee of for tomorrow because you just recycle everything, all the water on the urine in the space station, it gets recycled over and over up to 95%. And so also things from recycling and purifying the atmosphere, or even the solid waste. Now there's being a lot of work and research in trying to recycle even the solid waste, and then of course all the try to limit the waste of energy, transportation and stuff like that. So you can imagine all of these technologies can be applied to floating cities or sea cities in a very different way. So those are some of the most common kind of similarities and applications that we have in common between these two.
Mm-hmm. Yeah, and obviously then, we're talking about extreme examples, and being on a floating community is a much less extreme example than being in an isolated space station or being on a trip to Mars or even living on Mars, that sort of thing. So in terms of these technologies, what are more broadly, I know you're very bullish, you're very optimistic about all the different ways that technologies that have been developed for space and will be developed for space habitation and space travel have influenced and will influence terrestrial life. So can you talk a little bit more broadly about what are some of the things that you see either in the past or future, both, that are important innovations that have come and will come from the space industry?
Yeah. So there's all kind of like an endless list of technologies and the things that were initially developed for space, and then we have them in our everyday objects that just people don't know or forget about it. From like Velcro or like some the MRI scan for brains. A lot of some other technologies like materials that were used for the wheels of the space shuttle were actually ended up being used in like normal car wheels. There's all kind of like materials and applications like that got introduced and widespread in our current society. But other than that, or like GPS, for example, like GPS was developed for space initially, and now it's everywhere with our smartphones and airplanes and cars, whatever. So all these kind of technologies that initially were not even being imagined to be so nested in our society, now they're like just everywhere, and we can live without. So yeah, in the future, I see there's a lot of focus, a lot of momentum about doing research in the biological, medical field in space. So the main thing about doing experiments and research in space is using the microgravity environment, which is mainly weightlessness. So in a sense, the gravity that is balanced out, so you have this kind of weightlessness. And then the other thing is the radiation environment, which is all kind of nasty radiation coming from the sun and the space, and so you can use that to do all kind of other experiments. But so the main one that is usually used right now is the weightlessness environment, and you can imagine that without gravity, in a sense, quote unquote, you can test all kind of technologies or scientific phenomena associated with all kind of different things, like new medicines, new materials. There's like there's a 3D printer on the ISS that is testing a way to 3D print organs in space. Because if you think about it, like without gravity, you can do some kind of additive 3D printing much more easily, and for organs or like biological materials, it's way easier without gravity. And then like there's all kind of materials like crystals. Crystal growth is another big thing than in space. So like the fiber cables, so optical fiber cables, they're used to do transmission of communication. If you manufacture them in space, they're like the purest form of it, and so you can achieve just incredible performance and speed, and so it could have a lot of influence in technologies using this. So there's all kind of stuff like that, and so I'm very excited about all this kind of stuff being done in orbit around Earth. But then there's all kind of other stuff that we will learn by settling on the moon, on the surface of the moon. So reusing all. There's a big thing about being able to 3D print structures from the surface of the moon, from the regolith on the moon, or being able to build some power sources on the moon, maybe like fusion reactors, which will be, in a sense, more easily effective on the surface of the moon. And so there's all kind of stuff that you can do in space that can have a huge influence on Earth.
Wow. Well, as always, I want to remind our listeners that we'll have lots of links and additional information about the things that Roberto's talking about, so people can dig a little bit deeper and learn more about some of these technologies and all. Specifically to some of the energy systems that you talked about and are familiar with, whether it be getting back and forth to the moon or starting to think about getting to Mars and all that. Do you know much about kind of where we're at in terms of getting to a next level of speed or ability to just travel more quickly across the solar system?
So the main bottleneck right now to being able to go to Mars is like the speed, our current propulsion methods. So right now with conventional chemical rockets, which some like NASA and SpaceX and other companies are developing, they can get us to Mars in a timeline between 6 and 9 months one way. So that's kind of like a big bottleneck for many reasons. So you have to bring so much food and resources for astronauts to be in space, and then the astronauts need to live in microgravity for that long time, and then once you get to Mars, you can stay like a few months to up to a year, depending on the timeline, the profile of the mission. So you have to bring with yourself all kind of food and stuff like that for that amount of time, plus the return. So it's we're looking at least like a two-year trip to go to Mars and back. And so one of the biggest kind of momentums right now, it's also the idea of developing nuclear propulsion rockets. There's a bunch of projects right now being revived by some companies and NASA. And if we are able to develop those effectively, we can get to Mars in up to 45 days or like 2 months, for example. And so that would just simplify so much more first of all, the complexity of the mission, the cost, and we could literally just bring tons and tons of materials and resources to Mars to make a base on Mars. So I think one of the kind of like game-changing technologies would be definitely like new propulsion systems like the nuclear propulsions. But other than that, we still have to do a lot of accomplishments in using the local resources and being able to build structures on other surface of another planet, and that is being right now it's in the kind of in the plan with the Artemis missions, with going back to the moon. So we, of course, before going to Mars and being able to build all this kind of stuff, we want to validate and test it on closer to Earth first. So we would do this on the moon first, develop and validate all those technologies there first, and then use them to go to Mars.
Aside from Mars, is there any other particular planets or moons or anything that are sort of on the radar or that NASA's looking at as potential destinations?
There's been talks about human missions to Venus, because Venus has like a very thick atmosphere. Venus is, first of all, like the closest and most similar in terms of like size and mass planet to Earth. The only thing is there is something that we still don't know and we don't understand, and we want to study and learn more with upcoming. There's a few upcoming missions going to Venus right now. They're really really cool. We want to understand how the planet turned into a hellish environment. So, which is in a sense what also some scientists kind of. Basically, the scientists are trying to warn the world, about, because the worst case scenario from global climate change could be something that is right now happening on Venus. The Venus is it's an atmosphere very rich in carbon dioxide, and just made it such a strong greenhouse effect that is like the hottest place in the solar system. And so yeah, we want to study more how that happened, and hopefully that Earth doesn't get to something like that. But there's a few sections, a few areas in the atmosphere of Venus where the temperature is just right, the atmospheric pressure is good enough. There is a few components of the atmosphere that are not good for human survival, so we would need to filter those or whatever. But would be there's a few concepts about maybe even building some kind of floating cities or balloons in the Venus atmosphere where even human presence is possible. And then other than Venus, there's all kind of other places in the solar system where they're very interesting for other reasons, not specifically for human exploration, but for discovering life. There's places like the moon of Jupiter, Europa, and Enceladus, which is the moon of Saturn. Those have proven under surface water oceans where life, a very simple type of life, could exist right now. And so NASA is definitely like putting a lot of effort in sending some missions there to discover and measure if there is any signs of life.
The work about Venus and potential foreshadowing of what Earth's atmosphere could end up like is a pretty frightening scenario.
Yep.
In terms of the missions to the moon and setting up facilities on the moon and traveling to Mars as it relates to that nuclear propulsion, et cetera, I realize there's a lot of different calculations, but do you have a sense of how long is that going to take? How far away is that in terms of years?
Right now, if you look at the NASA timeline for going to Mars, that's being worked. Like right now, the main focus is the moon again. So then there is a new program called Moon to Mars. So once we get a good sense of what is needed to settle on the moon, then we will probably try and do human missions to Mars. But the first early kind of time where we could send humans to Mars is probably between the late 2030s and the early 2040s. So I would say like at least like 15 years before, and a lot actually will depend on the success, the results from the nuclear propulsion technologies. So I think we will definitely see humans landing back on the moon and hopefully, making habitats and settlements there. I hope to see people going to Mars.
What's next for you, Roberto? What are you most excited about in terms of your personal or professional journey?
After my astronaut analog mission with NASA, I really got excited about all these new space habitats and, living in space and, human space flight and things like that. So I'm really getting excited about the Artemis program, which will send, humans back to the moon and do that, sustainably and with a very strong international cooperation. So I'd love to have some kind of impact on that. So maybe try and work with NASA or other space companies in this new kind of era of space exploration. And then at the same time, I'm always like very, very excited about the scientific missions in space. Missions like the James Webb Space Telescope, which already now after 1 year and a half or something already changed completely our understanding of the universe, like making amazing discoveries. And there's so many other missions like the James Webb, which NASA is always working on, and being able to just work on something like that would be just an honor for me.
Neat. Yeah. Well, thank you so much for joining us on the Blue Economy Primer. It's been great to have you in town and to be able to show you around New Orleans a little bit, and really appreciate you coming on the podcast.
It's been a pleasure. Really, really good time here. Thanks, Greg.
Be sure to stay tuned after the closing of this podcast when we ask Roberto about the Fermi paradox. Thank you for joining us on the Blue Economy Primer. If you enjoyed today's podcast, don't forget to subscribe on your favorite podcast platform. Please help us spread the word, and be sure to visit our website at www.deepblue.academy, where you can find all of our available episodes, access important links and supporting information for each episode, send us your comments and or suggestions for potential guests and topics, get more information about our community engagement initiatives, and join our mailing list, as well as make a much appreciated tax-deductible donation to support our nonprofit education and research mission. Thanks again to the Dan Lucas Memorial Foundation and the Pontchartrain Conservancy for their critical financial and institutional support. Until next time, when we meet again on the ever-expanding horizon of the Blue Economy. So there's this concept called the Fermi paradox, which tries to explain or talks about why human beings haven't had contact with other intelligent life in the universe. Could you explain that a little bit to us, and what are your thoughts on what may be some of the reasons, or what are some of the key factors in that Fermi paradox?
Oh yeah, this is like one of the most interesting topics for me. I've been trying to learn and study as much as I could all the reasons and everything behind the Fermi paradox. Also because working at NASA, a lot of people, whenever I give talks or like talk to people, they always ask me about aliens or like life in the universe and things like that. So in a sense, it was also kind of like reasonable for me to learn more about this. So yeah, so the Fermi paradox basically was first thought by Enrico Fermi, who was like an Italian scientist, physicist back in the 30s and 40s. He was very influential in the discovery and the making of radio transmissions. And so when he was at lunch sitting with other colleagues, and he just brought up this kind of question where it basically said, where is everybody? Where are aliens? Where are other civilizations? You know, if you think about it, if the universe has been around for so long, and we know at least one advanced civilization that we are, why other intelligent and advanced civilization are not here yet in the realistic sense, you know, that we have seen and proved their presence and their science. And so to explain that, like the current, you know, we haven't had any proven reason of other intelligent civilizations. So to explain that, you know, there's all kind of different ways and different explanations. So there's one entity that is called the SETI Institute, the Search for Extraterrestrial Intelligence, which actively search in the sky for artificial intelligent signals coming from other stars or planets, and we haven't found any yet. So doesn't mean that, you know, there's no other intelligent civilizations sending signals in space, because we've just looked in a very, very small section of the universe for a very small time. And so one explanation is that, you know, we just haven't looked enough. And then there's all kind of other reasons, which I think it's the explanation for the Fermi paradox is kind of like a combination of all these reasons. Another reason is that to receive or see signs of intelligent civilizations, you have to align, you know, not only you have to have a planet in another star system where like life is possible, and then, you know, the evolution of that planet is long enough to have intelligent life, and then from intelligent life you have the right communication systems to reveal your presence or transmit in space. You also have to align temporally with our current technologies. So if, you know, we as a species, we've been able to do interstellar communication for about, let's say, 100 years to be conservative. But if I don't know, maybe like in 100 years or 200 years, we will use a completely different communication system that 100 years before nobody ever thought about using it. And so something like this could happen with other civilizations. Maybe they are using other communication systems that we have no idea can exist right now, and so we're just not aligned in that sense. And then there's all kind of other possible explanations. There's the dark forest theory, which basically says that if you are an intelligent species, you might be afraid of revealing your presence in the universe to other civilizations, because maybe those advanced species might want to go and conquer and exploit you. And so maybe you just don't want to reveal yourself. So you're just silent among the universe to try and hide from other intelligent civilizations. So yeah, there's all kind of different explanations. And so I think in general, especially from the latest results from the latest missions with NASA, like the Kepler missions discovering thousands of exoplanets around other stars, and then Hubble and other missions discovering so many galaxies and the stars in every galaxy. There's just an incredible amount of worlds out there, and the probability that some of those worlds have the right conditions and have life enough, developing for enough time to become intelligent is very credible to me. So it's just that we haven't had enough time to study this, and there's all kind of things that can happen at the same time that won't allow us to get in touch with them.
So again, we'll include some information about the Fermi paradox on the webpage related to your podcast here. In your opinion, when or how do you think we may end up having first contact, or do you think we will have first contact?
I think it would take a while. It depends a lot on how much effort is put by the different countries and space agencies. Right now, there's only very few ground observatories that are trying to detect intelligent signals from the universe. In a kind of comparison that the SETI people do usually is that we've been able to just sample a spoon from the ocean, from the entire ocean, and if you look at this little spoon of ocean water, you might not find any life there, because you just you haven't sampled enough. And so if we are able to sample and observe more of those kind of parts of the universe, we might be able to detect some intelligent signals. So I would say at least like it can take anything from like 30 to 100 years.
Great. Well, thanks again. Great to chat with you about all this, and we'll look forward to staying in touch and learning about all the exciting things you may be doing, including maybe being a mission specialist on a trip to the moon.
Thank you, Greg. It was a pleasure.